Primitive data types store single values, but the real world is complex. A registered user is not just an integer ID, and a moving vehicle is not just a floating point speed. To build scalable software, we must bundle variables together to create custom data types. As we have seen throughout this series across our 4 languages, the way we structure data directly controls how we build modern applications. In C, we group related variables together using a struct. You can create a vehicle structure that holds both speed and fuel capacity. However, C structures are strictly passive storage containers. They only hold data, not behavior. If you want to accelerate that vehicle, you cannot place that action inside the structure. You must write an external standalone function and pass the memory address of your structure into it manually. The major risk with plain structures is that any part of your code base can directly modify the values. There is no protection layer. If a rogue line of code accidentally sets your vehicle fuel capacity to -50, the compiler will not stop you. This complete lack of security is what led software engineers to develop object-oriented programming, commonly known as OOPS. OOPS solves this by locking data and actions together inside a single protected container. C++ serves as the direct bridge between traditional structures and modern classes. In fact, inside C++, a struct and a class are almost identical under the hood, with one fundamental rule. In a struct, every property is public by default, meaning anyone can access it. In a class, every property is private by default, keeping it hidden. C++ allows you to place functions directly inside the blueprint, transforming them into true methods. Java takes a strict zero-compromise approach to OOPS design. In Java, standalone structures and standalone global functions simply do not exist. Every single variable and method must live inside a class. You protect your internal state using explicit access modifiers like private and public, forcing all outside communication to go through structured getter and setter methods. Python takes a clean and flexible path to OOPS. You create a class using the class keyword, initializing your properties through the built-in dunder init constructor. While Python does not strictly enforce private variables at the compiler level, it uses naming conventions like an underscore prefix to signal protected data, and every instance method explicitly receives the keyword self, which tells the program exactly which object is currently being modified. The real-world analogy. To see the clear difference, think of a C struct like a bare mechanical engine sitting out on an open workshop floor. Anyone can walk up, grab a tool, and twist raw wires or alter gears directly. A class in OOPS is the complete finished car with a closed hood and a sleek dashboard. The fragile engine internals are completely sealed off. You do not touch the internal fuel lines directly. You simply interact with the safe, exposed controls by stepping on the gas pedal. From open data containers to fully encapsulated blueprints, understanding how structures evolved into classes is the bedrock of modern software engineering. If you enjoyed this breakdown, make sure to subscribe. In our next video, we take OOPS even further by exploring inheritance and polymorphism. See you in the next one.